Thank you for joining us for our February water and wastewater webinar, Things to Consider When Using Collection System Flow Meters. We will have a chat and Q&A function available for you to use during the presentation. Our host today is Darrell Kuta, Business Development Manager. And here's Darrell.
Good morning. Thank you for being here. I am Darrell Kuta, and I want to talk to you about things to consider in your flow collection system. So first of all, what is a collection system? It's a system of pipes or channels used to transfer water from houses, businesses, or industry to deliver it to a wastewater treatment plant. Some of these sewer systems may be defined as a combined sewer system, which is a combination of your storm drains and sanitary waste, which is combined through one pipe to go to the wastewater treatment plant. Other systems are known as separated sewer systems. As you can see by the picture, the storm drains are separated from the sanitary sewer to reduce the amount of water that goes to the treatment plants. So you need to ask, why are you collecting data from your collection system? You want to determine how much water is being transferred to the wastewater treatment plant during dry weather and during wet periods. And so what we're monitoring is the domestic sewage, water from industries, buildings, hotels. And what we need to do is determine the inflow and infiltration. And we're also looking at combined sewer overflows, because it's important to know when you have an overflow situation and you're sending water to the local lakes and streams. And you could also be using this for industrial billing. Other things to consider is, what measurement technology can you use? What equipment can be used for flow monitoring? How are we going to collect the data? How can you be more efficient with the data you're collecting? And to do all this, we need to determine what is the best technology for your application. So we need to decide where it's used, what flow technology, is it going to be with a primary device or with an area velocity sensor, depending on your application? How are you going to collect the data? And you should always validate your data. So now that you've collected it, is it good data? And another thing to consider is alarming. So if we do have an overflow situation or high level alarms, we need to consider how we want to be aware of it. So let's start with primary devices. So in your collection system, you may have primary devices and permanent applications, which could be a Weirs or a Flume. And primary devices are used with level sensors, which could be ultrasonic sensors as shown below, or a bubbler, or the commonly used sensor types. And with a primary device, we calculate the flow. So we use the level, multiply it by the height, and then the constant is dependent on the type of Weirs or Flume that you're using. Primary devices are good for free flow applications, but they are unable to detect reverse flow. So we need to make sure we have a good application. The water is going one direction and isn't backing up. Therefore, Flumes and Weirs are not good in surcharge applications. That's where we want to use a different type of technology. The common sensor types that are used with Weirs and Flumes or primary devices is the ultrasonic sensor. And how that works is you have an ultrasonic sensor, it transmits a sound wave, bounces off the surface or the water, reflects back, and it detects the echo. And it's a function of time, so it determines how long it takes to transmit and receive that signal to figure out the distance between the sensor and the water, which then can calculate a level. Now, all ultrasonic sensors have a deadband because it needs a certain amount of time to transmit, turn around, and then receive the signal, and that's why there's a deadband. You'll find on a lot of sensors the deadband is around 1 foot. However, that can vary depending on manufacturer. The other type of sensor that's used with the primary device is a bubbler. And how that works is you have an air pump inside your flow meter. It builds up air into an air tank. It releases the air through a control valve, which usually releases the air at about a rate of 1 to 2 bubbles per second. And then it measures the amount of pressure it takes, or head pressure, to push 1 bubble out of the end of that line. Now, if your application doesn't have a primary device, such as a open channel, which could be a round pipe or rectangular channel or a trapezoidal channel, you would use an area velocity technology. So with area velocity, it accurately measures flow under a variety of conditions. So it's considered an open channel, which can handle surcharge, and it can also have a full pipe. So even though it's a round pipe, it's normally open, and it can go full, it is still considered an open channel. And area velocity can read reverse flow. So what's that look like? To calculate flow, you need to know the pipe geometry. So we need to know if it's a round pipe or a rectangular channel or a trapezoidal channel. We need to know the depth of the water, which could be a ultrasonic or a pressure transducer. So when we know the depth, we can use that to calculate the wetted area. And last, we need a device to read the velocity of the water. So when we know these three things, when we have the depth, we can calculate the area. When we read the velocity, then it becomes area times velocity to give us our flow rate. So here's what that looks like. So we have an area velocity sensor, in-pipe area velocity sensor in the bottom of the channel. It has a pressure transducer, differential pressure transducer, to read the depth of the water to calculate the wetted cross-sectional area. It transmits a frequency into the flow stream and gets a return Doppler shift or frequency shift from all the air bubbles and particles in the water to determine the average velocity. Now, in an application like this, a lot of people ask, is the area velocity still accurate in the full pipe? Yes, because what happens is that in this case, we'll say it's a 1 foot pipe. If it becomes surcharged and it reads a depth of 5 feet, the flow rate is still accurate because it knows the wetted area at 1 foot is at 100%. And so at that point, the flow is proportional to the velocity. So you continue to get accurate flow readings even when it's open or a full or surcharged pipe. Other ways to read flow is a non-contact area velocity sensor. So like the laser flow sensor, it uses an ultrasonic sensor to read the distance to the surface of the water. When it knows the distance, then it can transmit a laser and read below the surface of the water, looking for the peak velocity. And then uses the same formula, area times velocity, to get us our flow calculation. So now that we've used a couple different technologies to determine where you may have a problem in your collection system, you could also use cameras to look for problems in the pipes, such as cracked pipes, or you can use smoke testing, and that will help you narrow down where you have a problem. So you wouldn't use this for flow monitoring, but once you've determined what section of pipe may have a problem, you can go a little more in depth with the camera or smoke to know exactly where we're getting the problem from. If there's cracked pipes or we have drain pipes from houses tapped in the line, you're going to see smoke coming from the house or through the ground. So what are some of the reasons behind the problems? Limited resources available to rectify the problem. Aging assets and infrastructure. When you have old pipes, they're going to break over time. Instances of infiltration are more frequent and become more painful the more problems that you have. So what are the indicators of your system performance? So number of customer complaints. So one, you can use flow meters to determine if you have a problem, or you can rely on your customers. If you have few complaints, there's probably fewer problems. But if we you start getting a lot of phone calls that they're having sewer backups in their area, you can pretty much determine that there's infiltration somewhere that's causing the problem, or blockages in the line. And then the volume of unpermitted discharges. You may find that you have a lot more flow going through certain sections of your collection system that you didn't plan on. And what does this all do? It has an effect on the operations at the treatment facility. So you're treating extra water that you weren't planning for or might not be able to handle. So where do we start? We need to develop an overall strategy on how we're going to monitor your collection system. We need to identify the good and the bad sewer lines. So where I would start is you start in the main trunk lines and start to work out to identify where your potential problems could be. And how do you do this? Develop a baseline flow during your dry weather period, and then identify the infiltration. So you're going to notice that during rain events, you're going to have a lot more water going through those channels. And you can always ask for professional help from engineering firms or from your local ISCO representative. So we need to begin to know your flow system. So when you get started, you want to send somebody out to identify the locations where you want to monitor flow. And a good idea is when you're investigating sites, document the details of the site, determine if it's a good application or not, if you're going to get valuable data from the site. Does the site present conditions that require special mounting? So you may want to fill out a form like I have on the right side that just indicates site conditions, as far as what type of pipe, round pipe, elliptical, the signs, the water depth, anything that's going to help out later, because after you start looking at 20 or so sites, it gets a little confusing as to which one you visited. So where are we monitoring? We're going to monitor in the in round pipes or rectangular channels, or with the Weirs or Flume. And why are we monitoring? We want to determine if we're getting inflow or infiltration into your flow system, and you want to identify problems in your collection system, such as cracked pipes, which may be one of the sources of your infiltration. So a couple things to consider during your meter deployment. When you look at the sites, determine if there's silt or debris or sediment that needs to be removed in the bottom of the channel, because if you don't remove it, that could interfere with your flow readings. Also note if there's signs of surcharges. That would indicate water or debris on the sides of the walls or ladders. Look for signs of fat, oils, and grease, on the side walls or ladder, and determine if you have adequate depth for velocity. So the type of technology you're going to use in there may determine on what your minimum water depth and velocity is through that channel. And are the flow conditions uniform? And so you're going to look at all these to set your expectations as to the type of data you expect to get from the site. And last, you want to validate the performance at the time of installation. So when selecting a site, you want to make sure you have enough straight run of pipe. So the general rule of thumb is that you have 5 diameters of straight pipe upstream and at least 2 downstream. Now, depending on applications, you may need more or less straight pipe. So what that means is if they have a higher velocity, you may need a longer straight run, possibly 10 diameters upstream. So let's just take a look at a couple of sites. So you want to select a good site. The example I have here shows a free flow pipe, no obstructions. We have uniform flow. This would be an ideal application that you want to choose. However, we all know that you can't always get what you want. Other applications you may run across is this shows a free flow application. However, it's a drop manhole. It doesn't mean you can't monitor here, but you just need to be aware of it and install the sensors properly. So we want to avoid the drawdown, which means moving the sensor as far away from the end of the pipe as possible. So you're going to go, depending on the pipe size, elbow deep, sliding the area velocity sensor into the pipe to avoid the drawdown. The reason you want to avoid that drawdown is it will give you a lower level, which would then calculate a lower area and then give you an overall lower flow rate. So we want to push it as far away from that to avoid that. Another application, this is a free flow application again. We have uniform flow going, or flow and velocity going through the pipe. However, the challenge is that we have really low level in this application, and so the water is just tumbling over the top of this area velocity sensor. It doesn't necessarily mean it's a bad application, but it depends on what you're looking for. If you're only concerned about the high flows, and you know the water depth is going to get up to 4 inches or 6 inches in this pipe, and you're not concerned about low flow, you could put an in-pipe area velocity sensor in there and be just fine. Or the alternative is to use a non-contact laser flow sensor, which would be able to read the lower levels and velocities. Other things to look for are surcharge. So in this, if you have a surcharge application, it doesn't necessarily mean you need to rule it out, but you need to set your expectations to realize that you may have standing or no flow going through this pipe. And as shown here with the meter floating, then you may want to consider moving the electronics to a separate area outside of that manhole to avoid it. Other applications you may come across is a bend in the pipe. So it doesn't mean that you can't use this application. It just it's something that you should be aware of. And then when you do your site inspection, you should mark that down that it does have a bend. So again, what you want to do with this is take the area velocity sensor, slide it as far up into the pipe away from the bend to so it has a little more free flow and straight pipe behind the sensor. Other things you're looking for are collapsed pipes. And this is part of the reason for doing the study, but when they do the site inspection, if they can, they should take a look at the pipe because if you have a broken clay pipe like on the bottom left, it's going to create turbulence. You're going to get inflow during rain events, or if there's other signs of debris. You know, it's just things that you need to be aware of, that the data at these applications may not be as accurate as if it was a better application. So as far as the inflow and infiltration, one of the most common and widespread issues facing many public works in the country. Many of these communities possess older infrastructure, which is directly responsible for repeat violations. You know, they're just taking on a lot more water. And then relatively high rainfall. So if you got a lot of rainfall, you got saturation, you're going to get more water into your collection system. So what are the typical sources of I&I? Cracked or broken pipes, roots, roof vents and drains into older infrastructure, older and improperly fitted manhole covers, combined sewer tie-ins, and illegal taps from houses such as sump pumps and downspouts. So what's that look like? In this graph here, we're just showing how there's on the lateral, we have roots going into the sewer line, which is could cause some blockage and allow water into the pipe. You have cracked pipes allowing more water in, and then you know, from the roof drains. So there's a lot of reasons why you could have infiltration. And so, you know, first you just need to identify where it's coming from, and then we could use some of those other technologies or even smoke tests to determine exactly where that infiltration is coming from. So how are we going to monitor the collection system? You could use a permanent flow meter, such as the signature meter with an ultrasonic or a bubbler. Or if it's you don't have a primary device, you can use the area velocity sensors, the 350 area velocity or 2150 area velocity sensors, and the non-contact laser. For portable applications, you'd want to use a logger, which would be battery operated or possibly solar powered. So now that we've looked at different types of flow meters, how we're reading the data, we need to collect the data. So one way to do it is direct connect. And so one of the things you want to consider on that is how easy is it to get to that application. If this is in the middle of a busy intersection, direct connection may not be the way to go. But if it is an easy application to get to, by all means use direct connect. Your other option is to use the cellular option. That way you don't have to stop the traffic to go in there and download the data. And so with the cellular option, you can have the data automatically pushed to a server, or we can use the SCADA system and use a Modbus output or analog output, depending on your application, to then transmit your data back to your main office. So now you've collected the data, where are you storing it? If it's a smaller study, you may want to keep it on your local database, on your laptop or PC. If you have a lot more people looking at the data and you need to share it with other people, you could save it on your server, or it could be cloud-based. So if you have other people outside of your office that need to see the data and you want to share it with others, cloud-based may be the way to go. So one of these cloud-based options is the Flowlink Global. And with that, you can have a modem on your site, and you can push the data automatically to your server, and then have it displayed as a dashboard view. The nice thing about this is that if you have a lot of sites, as you can see here, you can quickly look at all your sites at one time and identify green is good, so you don't have to worry about those sites. Could be in yellow, indicating that we had problems with pushing the data, or even red could be set up as an alarm, such as low battery or the sensor is in some type of an error. So now you quickly know that we have two sites that you may want to send your crew out to visit the site. Other ways to look at that is you can have it set up with a GIS mapping. So again, we just show pinpoints as to where the flow meters are located. And once again, green is good, red, we know where to send the crew out to visit and make changes as needed. Other people prefer to view the data as a graph, and so you should be able to select any one of your sites, get a little more detailed data. This graph is showing level, velocity, and flow, which can also be downloaded as a CSV file for people that are using other programs besides Flowlink to diagnose their data. Other things to consider is alarming. So you may want to have automatic alarming, letting you know that your batteries are low if it's a portable application, or if the level is too high, you're in an overflow, the flow rates have exceeded a certain value, or when you have rainfall or low batteries. So this will indicate when you need to send crews out to investigate the sites and do maintenance or retrieve data. Other alarming could be texting. So you could set it up for any of those conditions to send you a text to let you know when you have to go out and visit a site. Or you could get your alarm from an email. So now we've collected the data, we need to validate the data, make sure that we have good data. So what we're looking at here in the red line is our baseline flow. So during your dry period, you can create a baseline flow, and then you can easily see that during that rain event, now we have about 30,000 gallons of infiltration in this particular pipeline. So it just makes it easy to identify and determine how much additional water you have to treat. Other ways to look at the data is with the scatter plot. And so the scatter plot allows me to look at a lot of data at a snapshot. And so what we're looking for is, if it's a free flow application, you're going to see the level and velocity are both going to increase and decrease at the same time, indicating that it's a free flow. If this was a problem site, it would look more like a shotgun pattern. We'd have levels and velocities all over the place. So there's lots of information on the internet about scatter plots. So that depending on the patterns will change when the if it's gravity fed and pump flow, or if there's a siphon, it'll actually create different types of patterns. It's just something you need to look at and get used to for your application. But it's a great tool to get a quick look at your particular site. Other diagnostics, like seen here with the laser flow, on the top graph is showing the spectral average of the 5,000 Doppler points, or the 5,000 spectral readings when the laser is turned on. And so what you're looking for is a nice clean bell curve. The tighter the bell curve indicates that during those 5,000 readings, we're getting more consistent readings all at that same value. The graph on the bottom for the diagnostics is showing the ultrasonic. And so what you're looking for there is that the vertical lines are showing the min and max blanking distance, and you want to see that you have a nice bell curve or return signal in between those values. And the reason we do that is that if you were to pick up a second bounce, like shown over on the right towards the 40, that could give you an incorrect level reading if it missed the first echo and picked up the second. So by setting up proper blanking distance, will then tell you to narrow in on the levels that you're truly looking for. So on to area velocity. How does that work? So before I mentioned we put the sensor on the bottom of the pipe, it transmits a 500 kilohertz signal, and it's taken a weighted average of all the particles and air bubbles in the water. And as this graph shows, you have slower velocity towards the edge or the outside of the pipe, and the velocity gets faster as you get towards the center and towards the surface of the water. And you'll notice the peak velocity happens to be, just below the surface of the water. What that looks like in the background on a area velocity sensor is it transmits that 500 kilohertz signal, it gets the frequency shift or Doppler shift back, and then if it's a positive velocity, well, the return signal is going to be to the right side of 0 in this graph. If it had reverse flow or swirling, you're going to see that the signal is going to be actually both showing positive and negative return signal. So some of the things that you can also use for the diagnostics in the for determining if your area velocity sensor is working properly is the signal strength. The signal is the strength of the received energy, and it's reported as a percentage. So it could go all the way up to 100%, which is an extremely strong signal. In this case, 100% is usually too good to be true. Usually you're going to see a signal strength between 45 and 75%. If you have less than 45%, it just indicates that you have fewer particles and air bubbles in your flow stream, or the sensor is starting to become fouled, due to sediment or debris covering the sensor. And if it was all the way down to 0%, it just means that we have a very weak signal. We're not getting much of a signal back. So the gain is turned all the way up. The sensor's trying as hard as possible to get a good reading back. But the biggest thing is looking for consistency, because you could have a low signal strength, but as long as it's consistent, you're still going to get your desired result. So what's that look like? So if we have a strong signal, as shown on the right, we got a lot of particles in there, so we're getting a really strong signal back. It's probably going to be in the 80% range. The picture on the left, where we have clear water, we're getting a weak signal. I just don't have as much particles or debris in the water to get a good signal strength back. Now the spectrum is the amount of received signal to determine to be related to the velocity. So once again, 100% is usually too good to be true, and what you're looking for is usually in the 45 to 75% range. And so the spectrum strength is the amount of good return signal that we're hearing. One thing I watch on that is that, once again, we're looking for consistency. If it starts out at about 60% and then over time it starts dropping, that tells me that I'm starting to get sediment or debris starting to cover the sensor. And I can use that as a maintenance tool when to go out and clean the sensor. It gets down to 20%, send somebody out to clean it, my signal should go back up. So what's that look like in this example? Again, it's a fairly dirty water and uniform velocity, so I should get a strong signal strength back. The picture on the right, having a lot of grease, fats and oils in there and other debris, I'm going to get a weak signal because it's just having trouble getting the signal back. Now the spectrum is another diagnostic tool we can use. The spectrum ratio is the magnitude or the weight of the energy in the reported direction of flow. So before I mentioned the 100% is too good to be true, with the exception of the spectrum ratio. That's telling me it's looking at all the water coming directly at the sensor. So 100% is what you want to see on here. If we start getting down to 50%, it just indicates that the reflected energy reported at the direction at a minimum is 50 times or more than the opposite. And if it's down to 0%, it indicates that it's seeing equal positive and negative velocity all at the same time. So a typical application, you'd want to see 100%. As you see this start to drop, it indicates that we have sediment or debris or something in front of that sensor creating some swirling. So what's that look like? So 100% ratio is that all the water is clearly going directly at that sensor. If we have a poor spectrum, as seen here on the bottom right, we're starting to see some swirling, and so it would be picking up both positive and negative velocities and may end up with a 0 ratio. So now that we've looked at some of the diagnostics, we've determined that we have some good data. Whom do I need to send the data to? How are they going to see the data? Do they want it online? Do they want a paper copy? Do they want a digital copy? Things we need to find out. How are you going to deliver the data to them? Do they want it as a graph or a table? So that the table shows minimum, maximum, average flows, daily totals. So those are things you're going to need to find out who you're reporting to and what data is important to them. Other things while collecting the data is you may want to consider using a variable rate data storage. So if we're trying to collect a lot of data during a rain event, we could store data as shown on the left every 5 minutes, and then when the level gets above 5 inches, then it starts taking readings every 30 seconds. So we have a lot of detailed information during that event, and then it goes back to the normal 5-minute intervals once the water level drops. So other things to consider in your collection system: are you using the correct equipment for flow monitoring? Is your data accurate? Are you efficiently gathering your data? And you can also contact your local ISCO representative for help, or engineering firms to help you determine what equipment is needed and possibly where to install the equipment. So to find your local ISCO representative or distributor, you can go to our website, isco.com, and on the top right corner, there's a link to find your rep. You just put in your zip code or location, and it'll give you the information to your local representative. So I want to thank you for watching. If you have questions, please use the chat function and send that to us, and we will review and get back to you in just a few seconds. So one of the first questions, can you scroll up? Would an in-pipe area velocity meter work in an application where there isn't sufficient minimum pipe run for an ultrasonic sensor? Yeah, area velocity would be a better option than the ultrasonic. You would just need to push that sensor as far into the pipe as possible. So depending on the pipe size, if it's less than 15 inches, we have a spring ring that you can squeeze together, slide it in the pipe, and I've even seen people, take a pole or a board, to try to push it further into the pipe to get away from that drawdown. So as far as it is kind of application specific, we need to know, how deep the water is. Yeah, an area velocity normally would work with that. And I have seen some applications where they've just added pipe to that, where you may not have sufficient pipe, especially if it's a drop manhole. You may need to just extend the pipe and create a longer straight run. Okay. So next question is, yeah, do you compare between insertion flow meters compared to other companies? Well, as far as the insertion meters, I don't have direct comparisons for that. However, with an insertion meter, it could create more of an obstruction in like a sanitary sewer. So with an insertion meter, it's just more, it provides a place for rags, debris, and all that to get caught on. And so that's where, especially with sanitary sewer, I'd prefer a non-contact, such as the laser flow meter, to make the site a little more maintenance-free. There's a question if they can get a copy of the presentation. Yes. Is it?
Do you send it out? Okay.
So as far as the presentation, we are recording it, and it will be available on the ISCO website. So check back in a couple weeks, and we may have that ready for you. And we can also email it if you send in a request to us. You could just contact your local rep or contact ISCO and ask for the presentation, and we can send it to you. Yeah, next question is, could an area velocity sensor disrupt an ultrasonic sensor? As far as the actual frequency or the signal of it, no, it isn't going to interfere with that. But the placement of the area velocity sensor could interfere with it. If you put the area velocity sensor directly underneath the ultrasonic, yeah, that's going to create a disturbance in the flow and cause problems. But if you're concerned about just the transmitted frequency, no. The timing and usually the frequency are off, and that should not be a problem. Another question is, does a bubbler secondary device have a deadband? No, not really. No, the bubblers don't have a deadband on them. They're limited to the size of the bubble line, which is about 1/8 of an inch. So you'll read down to 1/8 of an inch. However, most flumes already have a recess in there, so the bubble line is below the bottom of the channel. So you can essentially, you can read down to 0, so there would be no deadband. Most contact sensors don't have a deadband. You know, with pressure transducers, it's mainly limited to ultrasonic sensors. Another question: will this presentation be offered again? It may be offered in the future, but you know, you can request to have the presentation or download it from our website if you want to give the presentation. But you know, depending on the number of requests, we don't have it scheduled in the immediate future, but that doesn't mean we can't. Next question, can you discuss alternatives for installations that do not require confined space entry? We have a couple options for that. You know, one would be the non-contact laser flow sensor that would reduce the amount of entries because the sensor would be mounted above the flow stream. And once the mounting bracket's in place, we have an extraction tool so you can easily remove the laser flow sensor and reinsert it at a later date. But for in-pipe sensors, depending on the pipe size, if it's less than 15 inches, we have what we call a street level installation tool. So what it is a spring ring with a strap attached to it. So you can attach poles to it, lower it down into the pipe, and then pull the strap assembly, slide the pipe in. So go to the ISCO website, isco.com, and look for street level installation tool. We have a nice brochure showing exactly how you could use that. Another question just came in. What flow meter would you recommend to pair with a ISCO 3700 auto sampler at a 24-inch outfall? I would use the Signature flow meter, and then we have the option to use a variety of different technologies for the flow meter. But with the Signature, we have a 306 sampler interface, and with that, you could set that to flow pace every X amount of gallons. We could use it to enable the sampler when you're looking for a certain event to happen. So if the flow rate exceeds X, then we can enable the sampler and then only take samples during that event period. So the 3700 would be a great option for that. Another question came in about what's the best sensor application when using a sanitary cleanout as a source of entry. So this could be difficult. So as far as with an open channel flow meter, we need the opening at the top of the pipe that you would be able to access to put in a sensor. So usually you would want at least a 1 foot opening on the top of that pipe. And if I'm reading this correctly, a cleanout is usually a smaller pipe going into the top of the pipe, so it may be difficult to get into. If you have pictures of that application, feel free to call me at ISCO. So again, my name is Darrell Kuta, and contact me at ISCO. You can go through customer service at 800-228-4373, or go to the website and get our contact information. And do we have any more questions? I think we're about finished here. We'll shut down and we'll keep the lines open for another minute or two. And if no other questions come in, I appreciate your attendance today. Question was, would the 3700, well, we have 3700 sampler and the Signature act as a liquid level actuator. So the Signature meter could act as the actuator because it would, you'd have a level measuring device attached to it. And so you could have it trigger or enable the sampler when the level reaches a given point. But we do have options for if you do not have a flow meter at your application. We do have what we call a liquid level actuator, which is like a conductivity probe or sensor that mounts above your flow stream, and when the water level comes up, hits the probe tip, it would enable the sampler and allow it to run on a time-paced program. So you would, as far as the liquid level actuator, you would usually use either the Signature or the actuator, not both at the same time.
Okay, got it.
All right, well, I thank you for your time, and please join us again for the next webinar, and have a good day.